Hello and welcome to the screencast on looping structures in MATLAB, where we'll focus this time on basic for loops. So in earlier screencasts, we've seen that in life, sometimes the flow of your decision making and problem solving is affected by choices that depend on certain conditions. For example, if it's raining outside, I'll wear a coat, otherwise not. In programming, that's referred to as a branching structure, and in MATLAB, we've seen that we implement those using if, else if, and switch case. But there are other times when you want to alter the flow of a program not by branching, but by repeating a task over and over again until a certain condition is met. For example, I might want to do something like, for every student on my class roster, display their social security number, or for every element in a vector, display whether the element is a prime number, or for every 10th element in a vector, plot the data point with a blue marker. All these instructions are iterations, or an act of repeating a similar task a certain number of times. All of these iteration tasks involve 5 basic components. There is a counter, a start value for the counter, a step size for the counter, a finishing value for the counter, and instructions to follow each time for each value of the counter. Let's look at the flow chart for the following task that's an iteration task. Given a vector, go through the elements one by one in order and display the square of each element. So we start by asking the user for a vector, which we'll call v. To go through the vector one element at a time, I have to have a counter that I will use to refer to the positions in the vector. And we've learned in previous screencasts that to access the entries in an array, like a vector is, the first element of the vector would be denoted v of 1, with 1 in parentheses. The second is v of 2, and so on. And I keep doing this up until I hit the last element of the vector. So there is a counter here, which I'm going to call I, and initially, since I want to start with the first element of the vector, I need to set the counter equal to 1. That's called initializing the counter. What I want the program to do is start at v of 1, calculate and display the square of that entry, then move on to v of 2, display the square of that entry, move to v of 3, and so on until I reach the very last entry in the vector. Now notice that this is telling me that I want my counter to start at 1 and step up by increments of 1. That is the step size, 1 step each time. Now let's think about the finishing value of the counter. Well, I want the program to finish when I, the counter, has ratcheted up to a value that's greater than the length of my vector. For example, if the length of v is 5, I want I to take on the values 1, 2, 3, 4, and 5, and then stop. So the finishing value of my counter is 5 in this case, and in general it would be whatever the length of v happens to be. Now that I know the counter, the start size, the step size, and the finishing value, I need to think about exactly what MATLAB should do while the counter is in the range that I want. Very simply, I want MATLAB to display the value of v of I squared. Once that's done, I want MATLAB to ratchet up the value of I by 1 and keep repeating this unless the ratcheted value of I exceeds the length of the vector. So notice in the flowchart we've created something new. There is a loop within the chart. When I iterate a task, that's known as looping, and loop structures in any programming language are a fundamental means of making certain things happen. In MATLAB, there are 2 kinds of looping structures. This screencast deals with one of these, the for loop. A for loop has the following general structure. I start with for, then I specify the counter name, equals, and then I create a vector, start, step, finish, like we would normally create a vector. I pass the instructions after the for statement, and then I end. And there you see the 5 basic elements of a loop: the counter, the start, the step size, the finishing value, and the instructions. Notice that in true MATLAB fashion, the start, step size, and finish values are phrased as a vector. Now let's go over to MATLAB and write a quick program that will do the task of squaring each element of a vector one at a time. So I have an M file started over here for our program, and let's start just like our flowchart started, to just ask the user to input the vector, and let's call that v. So the next thing on the flowchart that we saw was to initialize the counter, and we were calling that I. So let's just set I equal to 1, and we don't need that to echo to the screen, so we'll put a semicolon afterwards. So now let's start writing the for loop, the first line of which has the syntax. I have to say for, and then give it the counter name, I equals, and then the start value we said was 1, colon, the step size was 1, and then we have to put the finishing value here. But the finishing value for a counter actually depends upon the input. Generally speaking, I want the loop to stop when the counter has executed the instructions for the very last entry, or the entry whose position equals the length of the vector. For example, if I had a vector of length 4, I would stop after I hits 4 and executes the instructions. Now I can make this happen by going up a little bit before the for loop and declaring a new variable, which I'll just call finish. And I want this to equal the length of v, and actually the way to get the length of a vector is the command length. So this will look at v, determine its length, and set finish equal to that. And I'm going to use that as my finishing value right here. So this is going to create a counter that starts at 1, ends at whatever the length of the vector is, and steps by 1 each time. Now that I have the counter and the start value, the step size, and the finish value coded in, I need to give it the instructions. So I'm going to go down one line and notice it indents automatically. And the instructions were simply to display the square of the ith entry of the vector. So that would be v of I squared. And we'll put a semicolon there. So this will go through and start with v of 1, square it, display. And then that's the only instruction for the program except for incrementing the counter. In MATLAB, though, this ratcheting of the counter is done automatically. In MATLAB, once the block of instructions below the for statement has been completed, the counter automatically goes to the next value. In our case, it's going to be incremented by 1. If the step size were different, it might not be 1, but it is whatever we tell it to be using the step size. So in other words, although we saw explicit instructions in the flowchart to set I equal to I plus 1, in MATLAB that is taken care of automatically. I just have to type end. So now let's save this program and give it an appropriate name. I'll do a save as, and we'll call it vector square.m. And then we'll execute and go to the command window. And when I enter in a vector to say 1, 4, 10, and hit enter, it does indeed return the squares of each of the entries. So again, in the M file, just to walk our way through what MATLAB is doing, MATLAB first asks the user to input the vector, initializes I to be 1, and sets finish equal to the length of the vector. If I entered in, for example, the vector entered in a second ago would give a length of 3, and so finish is set equal to 3. Now it passes into the for loop, and for every I going from 1 to, in this case, 3, I'm going to display v of 1 squared, and then increment 1 to 2, display v of 2 squared, implement 1 to 3, display v of 3 squared, and the next time I increment, I will be beyond my finishing value, and so the loop ends. Now I can improve the code here in at least a couple of ways. First of all, I should really add a comment every time I go to a new box in the flowchart to let the user know what is happening. So that would be, for example, before the input statement, before the for loop, and so on. Now I won't do that right now, but if I were actually handing this in to somebody to use, I would probably do that. Secondly, there's actually no need to declare this extra variable finish right here. I can actually just replace finish with length of v, because that's what it is, and I can get rid of that line entirely. As you can see, if I save it and then run it again and pass it another vector, it still works. So doing it this way cuts out the middleman and keeps the workspace clear of all unnecessary variables. So let's recap what we learned in the screencast. We learned about iterating groups of instructions, and that is known as looping. And we've seen that MATLAB has at least one kind of loop, and there's another kind coming. The one we've learned about here is called a for loop, and it requires 5 pieces of information: a counter, a starting value for the counter, a step size for the counter, and a finishing value for the counter, and a set of instructions to execute. And the syntax for a for loop looks like this. We set up for counter equals, and then there's a vector on the right side of the equal sign with the start, step value, and finish value. The instructions encased below the for, and then an end. That's all for now. Thanks for watching.